Alrighty, let's explain how to read the periodic table. Before I start, you may notice on the wall in the classroom that you see the word group written vertically, and you see the word period written horizontally. Okay, that's our little memory device to help us remember which direction the groups go and which direction the periods go on the periodic table. So please keep that in mind. Here's our periodic table of elements. So if we remember that group is vertical, period is horizontal, we should be able to go back and answer the questions that we had in the beginning of the Kahoot. So if groups go vertically, then you guessed it, these vertical columns here are all groups. Okay? Every single one of these are groups. There's 18 groups on the periodic table. Don't worry about this part down here. We'll get to that later. Now, if the groups are vertical, then you guessed it, these must be the periods that are going horizontal or left to right. Okay, remember, we're not going to worry about this for right now. Now that we've looked at that, we're going to look at a condensed form of the periodic table now. This is how we'll work with it because the section in the middle, which is essentially groups 3 through 12, and I'll explain how we find that in a minute. You guys won't really need to know a whole lot about that other than that group is the metals, or they are metallic. So, our groups are these vertical columns. Well, the group or families have numbers. They also have names that we'll work on with a foldable in class. So, here are your groups. That's the number at the very, very top without the A. Without the A. That is the group number. Now, directly underneath the group number, we call it the A number. The A number equals our valence electrons. I abbreviate valence electrons like this. That means our valence electrons determine reactivity. And the valence electrons is what the groups have in common. So if you're ever asked what do groups have in common, you're going to simply answer the same number of valence electrons. So every element in this group has 4 valence electrons because it's under 4A. Every element in this group has 5 valence electrons because it's under 5A. Every element in this group has 7 valence electrons because it's under 7A. Now, there is one exception to this rule. Let's look at this one. This is group 18. You can't really see it. It's a little bit cut off. But group 18 is underneath 8A. Well, not every element in this group has 8 valence electrons. Because in order for it to have 8 valence electrons, it needs to have at least 8 electrons in it. And if we go back to what we remember, the atomic number for helium is only 2. Okay? So the atomic number is equal to protons and electrons. So this element, unfortunately, only has 2 valence electrons. Okay? But everything else has 8. Helium has 2. That's the one exception to this rule. Finally, we have our periods. And remember, we write period left to right, horizontal. So that's going to be this one. This is period 1. This is period 2, period 3, period 4, period 5, period 6, and period 7. Okay? And your periods equal number of energy levels. So let's recap very quickly. Our groups, they are vertical. Our periods are horizontal. Okay? Your groups have 2 numbers at the top of them. You have the group number, which is the number by itself, and then underneath it you have the A number. And remember, the A number equals your valence electrons, which determine your reactivity. Then we have our periods, and our periods equal number of energy levels. They equal the number of energy levels or rings that the element has. Think about when we were drawing Bohr models, we had our nucleus, protons and electrons, and then we had outside rings where our electrons would go. Okay, so this element or atom here has one ring, so that means it's in period 1.